All right. Welcome back, everyone, to the Black Brain Trust. This is episode 241, Space and Technology. I'm here with my co-facilitator, Gabe. What's going on, Gabe?
Hey, not too much, not too much. Just hanging back. I looked over the docket, so I'll be learning today.
It's always a learning experience here.
Yeah.
Please hit the like button as you come in. Share the video if possible. Docket and description beneath the video for you to follow along with. And we should get started. Maybe in the next 90 seconds. Wait for you guys to come in. Also, we had a great hangout last night on like education talk. So the Montessori schools, Montessori, right? That's how you pronounce it, Gabe.
Yeah, I think so. Yeah. Yep. Montessori.
Right. That was a
Mhm.
dope hangout, man.
Yeah.
Glad you
Indeed.
came through too. But you too bad you
Yeah.
left early, man.
Yeah, man. I had to, work the
Yeah.
next day and whatnot.
Yeah. There was a last piece on the docket.
Uh-huh.
We had two brothers from Haiti,
Oh wow.
actually, tech guys who created something called Surtab. I
Hmm.
think that's a Creole name, but basically they had built a tablet and loaded it up with black education software
Okay.
that you can teach your kids at home. So if you bought the tablet set,
Mm.
you can actually do homeschooling on your kids.
Okay.
So it was
Hmm.
definitely an eye opener because seeing two guys actually do that by themselves, that lets us know the tenacity that a lot of brothers have when their back is against the wall. So,
Oh yeah. Absolutely.
mhm.
Man, I kind of maybe on a little bit of that same point. Man, I have a nephew. He just turned 13 years old, and for years, man, I've been just trying to get him, just interested, trying to provide him with resources and everything to try to learn, different things in tech, kind of some of the stuff that I do. But oh my gosh, it's so difficult with the interest level of the young people today. It's just I mean, I literally have to be on his neck in order for him to like he appreciates it, yeah, but that long term making it stick thing is like difficult, especially when all he want to do is basketball and video games.
Right,
So
right. You got to isolate them. You got to isolate them.
yeah,
You got to get started early, right? So you can't wait until they're hitting puberty because that's the most
man.
difficult stages, right?
I
But
started when he was 9 8 9 years old. And he's yep. Go ahead.
no, I'm just saying that
Mm,
most of the time you see some of these tech guys like Elon Musk and Steve
yep.
Jobs and Bill Gates and those guys. They got started when they were 5 6 years old.
Yes.
So you take a 13-year old and you compare them to like a 6 year old. They're already 6 years behind the curve.
Yep.
So they're playing catch up at that point.
Yep.
But
And it's just
mhm.
difficult, right? It's just difficult because I'm like, I don't even know how to even get a little bit of interest unless we're going out to eat. Because 13-year-old, you just want to eat at that point.
Oh yeah.
That's pretty much his major interest is basketball and food.
Hmm.
So
No, but you have to make it group. It has to be a group dynamic. It's not
mhm.
so much of a one-on-one because
Yeah.
they're very social at that age. So
Hmm.
if you could demonstrate uh, the rudimentary things, some of the most basic things such as circuit boards, logic boards, and things like that.
Yep.
Um, there's a lot of kits you can buy off of Alibaba and stuff like that for like
Yes.
Raspberry Pis and stuff like that. So there's a lot of projects you can download from GitHub.
Absolutely. Yeah. There was something I got a breadboard set. So a
Hmm.
breadboard with resistors, transistors, some wires, and just like LEDs and little switches and things.
Hmm.
That's that thing is in pieces.
Is it because of you or because of him?
Because of him, and I think it's also because I guess it's not reinforced because I don't have any children, right? So
Hmm.
this is from afar. So I'm in a different state than he's in. So I'll get him these things, but the education of it hasn't been reinforced at home.
Hmm.
and the importance of it hasn't been reinforced at home. So it's only so much that I can do from afar. But yeah, but yeah, those sets are definitely there for those young people
Hmm.
learning those different concepts. Yep.
Yeah, you got to get them started with something like Nisby Junior.
Yep.
I do mentorship for Nisby Junior for
Yep.
pre-K to 12. So
Yep.
you're a part of that?
PCI. Yep.
Yep.
Yeah, the pre-college initiative. Absolutely. They had the summer programs. He was also in Detroit. They have a program called DAPSAP, called Detroit Area Center for Engineering and something. It's he was a part of that too. He actually won an award on the team. They did
Hmm.
like engineering projects, but they partner with Nesby Jr. with Nesby Jr. and PCI pre college initiative. So he was made sure to get him in that too. Yep,
Hmm.
that's important. Yeah, hmm
Hmm.
just that sticking factor.
Hmm.
Yeah,
Yeah, definitely, definitely. I think it's an environmental issue as well. So,
indeed.
all right, let me get
Yeah,
started. Peace to everyone in the chat, man. Raining woman, peace to you. You're always so reliable and so generous with your time and your contributions. So I definitely appreciate that. We appreciate that. Let me get started sharing my screen. AM1, man, we missed you on that hip hop as a science, man. Should have came through for that. We have to do another one, man, for your top 5 West Coast rappers, man. The West Coast spitters. We'll get into that again, though. All right, this one is from FoxBusiness.com. Walmart adds AI-powered cameras to more than 1,000 stores to reduce checkout theft. Should be interesting. Expand this out. Walmart is working to reduce checkout theft in more than 1,000 U.S. stores with the help of cameras powered by artificial intelligence. The retailer began investing in the surveillance program called missed scan detection several years ago in an effort to combat shrinkage loss due to several causes, including theft, scanning errors, waste, and fraud. Walmart spokeswoman Lamia Jenkins, you know who she is, told Fox Business on Monday. She said the company was investing in the program in an effort to help customers and make stores safer. Walmart takes the security and safety of our stores seriously. We want our customers to have a pleasant shopping experience and have invested over a $500 million to prevent, reduce, and deter crime in our stores and parking lots, Jenkins said in a statement. The missed scan detection program is only part of that effort. We continuously invest. We are continuously investing in people, programs, and technology to keep our stores and communities safe, she added. The AI-powered cameras, which use an algorithm to capture any items that aren't scanned properly during checkout, rolled out to more than 1,000 stores about 2 years ago, according to Business Insider, who first reported the news last week. Jenkins told Fox Business that Walmart has seen positive results since the cameras were added to the stores, adding that shrinkage has reduced overall. That's interesting. That's very interesting.
Mhm.
The U.S. the U.S. retail economy overall lost an estimated $46.8 billion in 2017 due to shrinkage, about 1.33% of sales, the National Retail Federation reported. Alan O'Hurley, CEO of Evergreen, which provides Walmart with the AI technology, said the majority of the checkout related issues are not intentional. In some instances, customers forgot to include items left at the bottom of carts or cashiers don't properly scan an item. People make mistakes in terms of shrinkage or loss. That's the main source. Or Hurley told Business Insider, adding that milk is a common item that's not scanned properly. People find it hard to scan milk. Sometimes they get frustrated and they don't scan it. He said,
Mhm.
"Yeah, I'm not following that because
I'm not following that either. A
it's a,
justification, at least.
yeah, that's a pretty strange thing. Because I mean, most items, right? point of sale system, if you look at the touch screen, it says enter an item, right? So if you get a
Yeah.
carton of milk and it has a five-digit serial number to it or a code number to it, you kind of just
Yeah.
enter that into the system. Like, I don't understand
Right.
what's so difficult about that.
I,
But it's
I mean,
AI
even as
powered. Go ahead.
right. I was gonna say even as a concern, I think it makes sense. People put things at the bottom of their baskets or the bottom of their cartons, but that's if you're getting a gratuitous amount of groceries. Usually, that's when people usually utilize that bottom carton, or if they're getting something very, very heavy. So I wouldn't. I mean, much loss. I don't know. That sounds like primarily theft. In my,
What
I
I mean,
don't. Huh.
what about the people who eat grapes while they walk around the store? I mean,
Yeah,
how does the AI powered camera handle that?
sure. I know that it says it concerns weight, but they don't. They they probably just count that as a loss anyway.
Hmm.
For margin. Probably already incorporated a certain amount of losses annually anyway, and they're like, oh, well, we're going over that margin that we already anticipated. So, because they even have scan codes on grapes and
Hmm.
oranges and all types of fruit that you would usually bag up, weigh, and then get a price for it. But I know Walmart has a lot of scanning for some of those normal vegetables and fruits. So I'm not sure where all these losses come from. But I don't think it's milk. I don't think
Hmm.
people just forgetting to scan milk.
Yeah, especially that
Personally,
they're lactose tolerant. So,
right, right.
hey, we got Lionel on the panel as well. What's going on, bro? You got something you want to add to this?
Hello, how you are, gentlemen? No, I don't have anything right now.
All right. Yeah. So, what's your take on AI technology, Gabe?
Well, I think it's like slowly but surely. Well, I wouldn't even say slowly. It's surely but quietly being incorporated into a lot of technologies that we use today. I think definitely initially, at least the machine learning aspect is definitely in a lot of what we use, finding behaviors, finding patterns in humans, the ways they interact with technology and places and things. I think a lot of that is all already here. I think they're just finding scale. I think it's just scaling now, right?
Hmm.
Scaling larger. So
Hmm.
it's kind of how I see it currently.
Are you leveraging AI in your daily operations at all?
I wouldn't say leveraging it, not in a heavy interaction with it. I
Hmm.
think we do a lot of development of technologies or more utilizing particular tools to accomplish a goal.
Hmm.
But I wouldn't say I'm developing AI technology. Some of it is incorporated in a number of the products that I use.
Hmm.
Yeah.
Yeah, I used to work in security automation myself in the cloud. So,
Hmm.
um, creating workflows and processes
Right.
to get, you know, remedial tasks, down
Yeah.
down to a science. So
Hmm.
I think that that's always a major skill set right now to have. Um,
Yeah.
I think a lot of brothers are missing out on this. This is it's like in the very early phases. You'll probably see it.
Hmm.
You'll probably see maturation for um, AI probably by 2022.
Yeah.
Um, you'll see like complete maturation. I'm saying by 2022.
Hmm.
I think right now there's still a lot of kinks um, in terms of the development because I think TensorFlow um, is now at 2.0, and I've
Hmm.
heard rumors about it reaching to 3.0, probably by next year or something like that. Next
What's that?
iteration. Tensor
TensorFlow.
TensorFlow is the AI platform that Google uses for
Hmm.
Google Duplex. You can
Hmm.
download it; it's free. Um,
Yeah.
most of the your input for any AI platform, including TensorFlow, is going to be labor intensive. So
Hmm.
it's about knowing what you want and then building the data sets to add to it.
Right. Right. I can see that.
Hmm.
And I think that right now a lot of people see it as primarily, academic in nature
Hmm.
when and more of like development. But I think that it's going to become more, you're going to find more use cases from a do-it-yourselfer, right? It's more use cases and practical uses for it. Because I think that a lot of where we use it in my practice, we would go into a particular environment that's a network, right? And then we would go ahead and use the AI technology with some of our products to run in order to understand what normal looks like, as it concerns normal good traffic, normal good network traffic. And then that baseline would be used to compare against situations like production environments. So it would be a continual compare and contrast between what normal traffic looks like, and when anomalies come in, that's when you would get alerts and triggers and things, right? Just learning a network. So
Yep.
that's very practical. I could throw it on my own home network and use that. So
yeah, my ASUS router has that built-in anomaly detection. So
right.
Yeah. Let me get to this next article.
Sure.
Hey, Paul Bryan is on the line. How are you doing, my brother?
Hey, what's up?
Hey.
Good evening, gents. How are you?
What's going on, Paul? How you doing?
All right, I'm good.
All right. All right, let me get to this next article. This one is from zdnet.com. MIT, we are building on Julia programming language to open up AI coding to novices. We just got finished talking about this.
Right. I was just going to say, you were just saying that, yeah.
Yep. MIT, where the popular Julia language was born, has created a probabilistic programming system called GEN, which it says will make it. Let me expand this out. Which it says will make it easier for newbies to get started with computer vision, robotics, and statistics. GEN is part of Julia, which MIT researchers debuted in 2012. Over the past year, Julia has become one of the world's most popular languages, currently sitting in 44th place on the TO Programming Language Index, just behind official Android language Kotlin, Microsoft's JavaScript superset TypeScript, and Mozilla created Rust. According to MIT, GEN's creators incorporate several custom modeling language into there's some feedback coming from somebody on the line. I think it might be mine now. Which allows users to create AI models and algorithms without having to deal with equations or manually write high-performance code. But the system can also be used for complex tasks such as prediction, which may be of use to more technically competent researchers, according to MIT. The name GEN comes from the system's purpose to fill a gap in general purpose probabilistic programming, according a paper by MIT researchers. That's poorly written there. Existing systems are impractical for general purpose use, they write. Some systems provide restricted modeling languages that are only suitable for specific problem domains. Others provide universal model languages that can represent any model, but support only a limited set of inference algorithms that converge prohibitively slowly. The system allows coders to create a program that, for example, can infer 3D body poses and therefore simplify computer vision tasks for use in self-driving vehicles, gesture-based computing, and augmented reality, AR. It combines graphics rendering, deep learning, and types of probability simulations in a way that improves a probabilistic programming system that MIT developed in 2015 after being granted funds from a 2013 Defense Advanced Research Projects Agency, DARPA, AI program. The idea behind the DARPA program was to lower the barrier to building machine learning algorithms for things like autonomous systems. One motivation of this work is to make automated AI more accessible to people with less expertise in computer science or math, says lead author of the paper, Marco Cusumano Towner, a PhD student in the Department of Electrical Engineering and Computer Science. We also want to increase productivity, which means making it easier for experts to rapidly iterate and prototype their AI systems. In the same way that Microsoft claims it is democratizing AI, the MIT researchers are aiming to enable data science for everyone. So, let me read this one last sentence. MIT also claims to be one-upping Google's popular AI framework, TensorFlow. I just got finished talking about that with Gabe, which helps users create algorithms without doing much math and relies on a Python language API. MIT says TensorFlow is narrowly focused on deep learning models and might not be fully delivering on AI's potential. So I talked about TensorFlow with Gabe just now, and TensorFlow is probably moderate in comparison to this very low-level system by MIT. We just got finished talking about AI being one of the skill sets that's going to be necessary in the fourth industrial revolution. So these fourth industrialized systems are going to require some form of AI knowledge. They've lowered the bar now where you don't even need a whole lot of math. So even if you are weak in these areas, you can still get into the game. I think this is an excellent way to actually get into information technology. What do you say, Gabe?
I think that's interesting. So when you say get into, I'm trying to think of, someone going from zero knowledge to being able to actually be marketable in this particular field. Are you thinking that they would need to develop some type of developer capability with this particular language that they Julia language, or I think R is another language that AI uses?
Well, for machine learning, you would use R in terms of data science. You wouldn't use R outside of that, to my knowledge.
Okay.
Go ahead.
But like with Julia, so like I'm just thinking of some steps, right? There would be somebody who's like, oh, I'm interested in AI. Would they go to some type of boot camp? They find different resources in Julia. Then they'd be able to do some home projects or something, or have their own GitHub repository with some samples, and then they would market themselves. I'm just trying to think of how
you get an internship, if anything.
Got it.
Most companies would do an internship before they even bring anybody on.
Right. Okay. Because a lot of what I see today in AI is definitely in the area of academia. Like a lot of people will not listen to what you're talking about unless you have a master's or a PhD in machine learning.
Yeah, you wouldn't really need that, right? Because even now, I think even Lionel can kind of vouch for this. You can get a nano degree from Udacity.
I've heard you guys talk about those. Yeah.
Yep. Companies are looking at it. Mark Cuban, billionaire owner of the Dallas Mavericks, did exactly what I've been telling guys on this panel. What we've been telling guys and people on these hangouts to do. How much time you need to study, where you should study, what sources you should go to. We cited all these sources and whatnot, so you don't really need a degree for this. Companies want people just as soon as tomorrow to get started. It's just a matter of your acumen, right? How well you can adapt to some of this new stuff.
What are some roles? Because are these like analyst roles? Or
no, these would be like front end developer or so on and so forth, man. I would say they're probably more about ops.
Okay, so like DevOps and
DevOps is a methodology, but they would just be ops, right? So they were working some form of operations role. I know you have anything you want to add to this?
Yeah, I agree. I see more and more people going to these websites we always talk about, getting their degrees and getting certifications, because they can put them on their LinkedIn profile, beef up their LinkedIn profile, and now more and more of this information is coming out. That's actually what I want, this group to do to start to get into things, help each other, network, be far linked up, and make ourselves more presentable in the ether.
Now, for those of you listening, Lionel actually has a blockchain study group. You should actually join it if you have not already done so. Lionel, if you could drop the link in the chat or whatever it is that you do to advertise this.
Yeah, I'll put my email in the chat, and you all can contact me. We started today. Type that in. We're doing certification on one of that.
I know you got a lot of
feedback. Oh, okay.
Whoa.
Yeah, what happened to that?
That was something.
How about now?
You're good now.
Yeah.
All right. Yeah. Well, we started today. We're doing a edX certification where is the certification on edX is free. You just have to pay for the certification. We're putting a LinkedIn profile, but that's the base certification. Everything else from there will be easier once you learn that base information from that certification, which is free. Everything, all the other certifications are paid certifications, but like I said, I want everyone that's going to be in there to be about doing certifications and not just there talking about what's going on and whatever. Right, gospel, yeah.
Who got pregnant?
Exactly.
Yeah, speaking of artificial intelligence and machine learning, Dr. Phoenix, who's in the chat, is working on a machine learning or deep learning project himself in the healthcare field. So we know just from having these conversations and reading these articles and disseminating this information that there is a viable market for this. And now they've lowered the bar to the point where you don't need a whole extensive math and engineering background for this. You can actually pick this up, with a few weeks of classes and whatnot. My rule of thumb here is this: you got to spend at least 90 minutes a day going over the material. I think anything more than 90 minutes in an adult's day is a little bit extensive. I know Asians study at least 3 to 4 hours a day, but they have a different, they have a completely different mindset. But for us, man, I think 90 minutes is like the bare minimum that you should be spending. Or I think that should be the average. Sorry, it should be the average that you should be spending reading over the material that's gonna help you going forward. What I find is that if you study too much, it makes your brain hurt, and then you lose a lot of information. I remember early in my career, I used to study a whole lot. I used to study from like 10 a.m. to 2 p.m. in the afternoon at the library, and then when I go take my exam, my certification exam, what I studied for wasn't even on the exam, so I overstudied. So you got to make sure that when you do study, when you do read and you study, you got to make sure that you're digesting this stuff in sizable quantities. You don't want to go through a whole entire 600, 800 page book in a day. That's stupid. That doesn't even make any sense. Gabe, you have anything you want to add to that?
It kind of along the same lines of studying. I think that even another thing that I've done, especially with studying for certifications, is finding the capability to lab up things, right? To be able to apply them into a particular setting. So, example, right? I was learning about a lot of networking, learning a lot of different protocols that go over the network, right? DHCP, Dynamic Host Configuration Protocol, and then like SNMP, and then kind of like BGP, all these kind of Windows and just overall like ARP, all these protocols. So I'm like, okay, I'm learning about what these things do, what they communicate with, what OSI layer they communicate on. But I'm like, okay, what do they look like? Like I'm looking at a packet, I'm looking at a frame. What does this look like? So I go and just try to find samples, right? And a lot of times this can be identified on a network in what you call like a PCAP file. So I'm going online, I'm trying to find PCAP files that show this different traffic on it. And then the tool that's used a lot of times is Wireshark in order to evaluate these things. So I'm finding PCAPs with all these different protocols in it. I'm being able to capture traffic. I'm being able to look at what do these packets look like actually on the network. So then now it's not only learning, but also seeing what it actually looks like, being able to see it in an active environment to be able to understand the concepts. I think that really learning it and reading it and then solidifying the concepts in a lab environment has really helped me to solidify a lot of the concepts that I learned. So,
yeah. And I recommend Pearson Publishing IT books if you're gonna study for IT. Those books are impeccable because the content that's in there before you even start the chapter, it will ask you several questions. Do you know this? And do you know this will predetermine whether or not you should read this chapter, because if you already know it, then don't waste your time. That's how they see it. And they have exercises in the book that will go over things like PCAP and how to read a PCAP and things like that, like Gabe was just mentioning. So definitely look up those books. Go to Pearson IT certifications on Google, and it will take you to the website. And they have great deals every single day. Put your name on the mailing list, and they'll usually send you a deal every single day on different IT certification books and different videos and stuff like that. So
yeah, absolutely.
Yep. Chaos Reigns says, but that's a good thing, Mike. Your brain should hurt. It means you're putting in work. That's true and it's false. So you're reading a whole lot, but you're not absorbing a whole lot of material. Absorbing too much material at once is only going to make your brain bust. If you ever been to a boot camp, and maybe Gabe, you can probably speak to this. A boot camp, man, is intensive, man.
Oh yeah.
It's intense.
Chicken from a water hose or fire hydrant, whatever they say.
Oh man, yes, man. It's like trying to it's like trying to drink a Kool-Aid Lake or something like that. It's not even worth it, man. Your brain you walk away with your brain hurting. The last boot camp I went to was about a year or so ago for web application penetration testing. And for Tim Tomes. I don't know if you ever heard of Tim Tomes before, from the military.
No, I haven't. Yeah.
Oh, he's dope, man. He's so dope. But he had a boot camp.
Suite.
Yeah, a lot of burp suite, a lot of he's on another level of cybersecurity that I haven't seen before, man. You know, I'm a big stickler for him. But his boot camp was so intense from 8 to 5, man, or 8 to 6, something like that, for a whole 3 days, man. I was like, oh, this is beyond what I anticipated. And you have to get up every like 45 minutes or so to take a break, because there's just too much information. And he's like a Gatling gun, man. He's like a machine gun. He just keeps going and going because he's passionate about it. But at the same time, I take a lot of notes by hand. I don't know about you, but I take a lot of notes by hand because it just helps me learn better. And you know, he just keeps going off like a Gatling gun, man. And I can only keep up so much. So definitely good stuff.
I agree.
All right, let me get to this next article. This one is from EurekaAlert.org. Artificial intelligence controls robotic arms to pack boxes and cut costs. Expand this out. Rutgers computer scientists use artificial intelligence to control a robotic arm that provides a more efficient way to pack boxes, saving businesses time and money. We can achieve low-cost automated solutions that are easily deployable. The key is to make minimal but effective hardware choices and focus on robust algorithms and software, said the study's senior author, Kostas Berkis, an associate professor in the Department of Computer Science in the School of Arts and Sciences at Rutgers University, New Brunswick. Berkis, Abelslam Bodoris, I think that's his name, and Jing Jen Yu, both assistant professors of computer science, formed a team to deal with multiple aspects of the robot packing problem in an integrated way through hardware, 3D perception, and robust motion. The scientists' peer-reviewed study was published recently at the IEEE International Conference on Robotics and Automation, where it was a finalist for the Best Paper Award in Automation. The study coincides with the growing trend of deploying robots to perform logistics, retail, and warehouse tasks. Advances in robotics are accelerating at an unprecedented pace due to machine learning algorithms that allow for continuous experiments. This YouTube video shows a KUKA robotic arm tightly packing objects from a bin into a shipping order box, 5 times actual speed. Tightly packing products from picked from an unorganized pile remains largely a manual task, even though it is critical to a warehouse efficiency. Automating such tasks is important for companies' competitiveness and allows people to focus on less menial and physical taxing work, according to Rutgers scientific team. The Rutgers study focused on placing objects from a bin into a small shipping box and tightly arranging them. This is a more difficult task for a robot compared with just picking up an object and dropping it in a box. The researchers developed software and algorithms for their robotic arm. They use visual data and a simple suction cup, which doubles as a finger for pushing objects. The resulting system can topple objects to get a desirable surface for grabbing them. Furthermore, it uses sensor data to pull objects toward a targeted area and push objects together. During these operations, it uses real-time monitoring to detect and avoid potential failures. Since the study focused on packing cube-shaped objects, a next step would be to explore packing objects in different shapes and sizes. Another step would be to explore automatic learning by the robotic system after it's given a specific task. The lead authors are Raoul Shom and Wei and Tang, doctoral students in the Department of Computer Science. Co-authors included doctoral students. I'm not going to read the rest of that, but that's what the credits. But the same jobs that brothers be looking for, working at these warehouses, I can tell you right now, these jobs about to be replaced, man.
I remember a conversation I had with Mike Risley. We were talking, and we were talking about automation and robotics. And he was saying that it's easier. I forgot how we got to this point, how we got to this point when he said this, but I know he was saying, people will, think that it's never going to happen to them because they have this specific type of job, blah, blah, blah. But he said it's easier for them to design a different shelf to have the robot work better off of than to design an entire new robot that's focused on replacing your job. So what I'm trying to say is it's easier for companies and businesses to redesign maybe a store in terms of the shelving where the robots are more efficient, therefore thereby eradicating menial jobs. So I say it to say people may think that automation and robotics can't take their jobs. No, not right now. Maybe not in another 2 to 3 years, but after a while, you're going to start to see the cutting off of menial menial jobs. You're going to start to see. You're going to wake up one day. You may look at the news, and they may talk about this robot that can now do this. So it doesn't seem like it's possible now, but in the future, it can be, and that's what we're trying to say. We're not trying to say, don't bother to go to work tomorrow because your job's not going to be there. No, what we're saying here is this is on the horizon, and it's coming on the horizon. So before it gets here, prepare yourselves by doing these things. We're giving you advice.
Yeah, absolutely agree with that. Last year I attended the NSBE conference, National Society of Black Engineers conference in Detroit, and there was actually a presentation about a new method. Well, you actually using machines in order to make industrial environments more efficient. So you know how you have like the forklifts, you have people around walking around with hard hats, people moving heavy equipment, people on lines. They were just saying, "Hey, we have a solution that would help not only to make this process more efficient, but even companies to be able to save. Because if you're working in a warehouse, there's certain things that the business has to provide, like heating and cooling and lights and just those safety is a huge concern in those environments because you have humans and equipment, right, raw materials, but also forklifts and all these things moving around where people get injured all the time. I mean, if you just take the human element out of that, you have a cost savings and you also have a safety savings, right? You don't have these safety stand downs all the time. You just have the robots doing a lot of the work. And even as it concerns space, because you can possibly do more of a vertical type of build, right? You can have machines that stack things more vertically, where now you have more where people use forklifts and things in order to put it I guess, at a height that people are able to reach or be able to evaluate. So, yeah, I think that it was a lot that was very interesting about how they were saying taking the human element out of that industrial environment would be cost savings, safety savings. And they had one other piece that they spoke about that would be beneficial to a business model. So, yeah, man, like you
I'll
said, it's coming.
I'll, I'll even throw in break rooms, microwaves, the area where you
Yeah,
go warm your food up. Little small things like that, where a cluster of humans will not, the absence of a cluster of
hmm,
don't need. Um, just creature comforts that are around a job site.
yeah.
So that's space, and you can take that space up.
Yeah, and you don't
Hmm.
have to pay robots a pension. You don't have to pay for their health
At,
care.
at
So,
all,
Right.
yeah,
at all.
they don't require overtime. Over 40 hours. Anything over 40 hours is overtime. So they can work 24/7. Uh,
Background checks.
yeah,
Parking lot.
yeah. Now they've been talking about creating a robot tax as a way to
Mm,
compensate for those jobs that will be replaced by automation. But you know, companies will figure out a way to get around that. I mean,
right.
they'll probably move to like the border of Mexico or something like that, and then set up
Yep.
a facility with all those robots in there, just to get around all those sanctions and stuff. Or they may move a lot of that stuff to Africa, um,
Hmm.
just to get just because there's so much vast land and real estate available for them to set up shop over there. But the main point to be taken here is that the menial task that a lot of African Americans or ADOS seem to thrive on so much,
Yeah.
that stuff is going to be gone. It's going to be gone in the next couple of years, and
Hmm.
you're going to be out there beefing with robots, man, instead of
Yeah.
beefing people on panels.
I think even probably one of the biggest, I guess, things that's slowing that process most is probably the unions, right? The workers' unions.
Mm-hmm.
That I know that in Detroit, I have, because the plants are huge in Detroit, the automotive plants.
Mm-hmm.
Because not only are there like Ford, Chrysler, and GM headquarters, but in their plants, but there's also the automotive suppliers, right? Like a Yazaki or like a Denso or like a Bechtel. Like
Mm-hmm.
they have facilities there, wire harness organizations. So I think one of the biggest things that's holding it back definitely are the unions, and the unions are actually pushing for training for their union workers, for them to be able to keep up with the technological advances, right?
Mm-hmm.
Not only being a line worker, but also an individual who's able to be a technician, an individual who's able to be an engineer. So they give a lot of like education and training towards individuals who desire to go higher. So yeah, I don't know the exact numbers there, but I know several of like my peers who are starting to take advantage of those type of programs. So yeah.
But that's the key word, who desire to go higher.
Yeah. Yep. Many that don't. They like to do that overtime and stay on the line longer, you know.
Yeah, we covered an article a year or so ago talking about the first restaurant in the country. It was in Boston that has it's all automated. It's not McDonald's or anything like that. They actually cook your food literally on a skillet and all that stuff, and then serve it to you. The robots serve it to you.
Oh wow!
So this is where we get into. I mean, we covered an article before, maybe a few weeks ago, about automated dishwashing as a service. So they have these machines that basically rack up all these plates and bowls and forks and knives and stuff, and wash it all for you, and then repacks it for you, and then ships it back to you.
Wow.
So the brothers who were coming home, from the penitentiary, who looking for that dishwashing job, you're a day late and $1 short, brother.
Man.
All right, let me get to this next article. Hyperledger.org, introducing Hyperledger Transact. Let me expand this out. Today, we are excited to announce our newest project, Hyperledger Transact. Transact represents a continued evolution at Hyperledger towards greater componentization to allow rapid, responsible adoption of new blockchain technologies. Transact provides a platform-agnostic library for executing transactions with smart contracts. It allows us to more rapidly integrate a variety of smart contract technologies such as WebAssembly across Hyperledger family of projects. Transact is informed from experiences in design in multiple Hyperledger frameworks, including Hyperledger Sawtooth and Hyperledger Fabric. Smart contracts are a fundamental building block of distributed ledgers. In distributed ledger frameworks, a transaction represents an intended change that is submitted by a user. Transactions are interpreted by smart contracts, which update the current state of the system as a result. Existing solutions for smart contract execution are generally tied to a specific distributed ledger implementation, which limits the code's reusability. Hyperledger Transact will reduce the development effort for distributed ledger solutions by providing a standard interface for executing smart contracts that is separate from the distributed ledger implementation. Hyperledger Transact makes writing distributed ledger software easier by providing a shared software library that handles the execution of smart contracts, including all aspects of scheduling, transaction dispatch, and state management. Hyperledger framework level projects and custom distributed ledgers can use Transact's advanced transaction execution and state management to simplify transaction execution code in their projects and to take advantage of Transact's additional features. More specifically, Transact provides an extensible approach to implementing these new smart contract languages called smart contract engines. Each smart contract engine implements a virtual machine or interpreter that processes smart contracts. Examples include Ceph, which processes Ethereum virtual machine smart contracts. Sabre, which handles WebAssembly smart contracts. Transact also provides SDK software development kits for implementing smart contracts and smart contract engines, which makes it easy to write smart contract business logic in a variety of programming languages. Hyperledger Transact is inspired by Hyperledger Sawtooth and uses architectural elements from Sawtooth's current transaction execution platform, including the approach to scheduling, transaction isolation, and state management. Transact is further informed by requirements from Hyperledger Fabric to support different database backends and joint exercises between Sawtooth and Fabric for flexible models for execution adapters. Transact is fundamentally a transaction processing system for state transitions. State data is generally stored in a Merkle radix tree, a key value database, or in a SQL database. Given an initial state in a transaction, Transact executes the transaction to produce a new state. These state transitions are considered pure only because the initial state and the transaction are used as input. As a result, Transact is agnostic about framework features other than transaction execution and state. Awesome, right? There's so much Transact being happening in these in this whole entire paragraph. I think I'm a little bit Transact out. Lionel, you're a blockchain aficionado. Could you
Yeah.
Hyperledger?
Hyperledger is the enterprise branch of blockchain. Where blockchain, you use consensus, open, public, permissionless. Hyperledger is the enterprise, and I actually want to go into Hyperledger also in the blockchain study group because it's a part of it. And there's so many avenues to go into this that I feel that this is one of the fourth industrial revolution that is streets that is so plentiful with side streets and off streets that you can go into and make a living. So Hyperledger, you see you talked about Sawtooth, you have Quorum, you have R3 Corda, well, you have Corda. It's so many where each focus on a specific thing, and you can become the SME of that specific thing. And it's important that I understand you hear us talking on the panel, and well, the people that come on the panel, or the people that are in the chat that's listening to the show, the after show, not the after show, but the rewatching this on their spare time. I understand that you all are listening to us, and you all talk about this, and you hear us talk about this, but it's important to understand. Yes, we're giving you information that you can take and say, hey, well, this is coming up. This is for the Industrial Revolution, and it's good to know that. But at some point, come join us and be a part of us getting these certifications, going and get these nano degrees and so forth. And you don't have to do it by yourself. It's other people that are here that are doing the same thing, where we can go into this fourth industrial revolution. A lot of these technologies overlap with each other, and you can you can cross pollinate. It's important to not just know it, but know how to think. Well, what you can do with this, why I can do this and do this. So it's important. But Hyperledger is the enterprise version of blockchain. You see banks using it. You see JP Morgan Chase using Quorum, which is the enterprise version of Ethereum. I just read a report where, well, Goldman Sachs was already back in the crypto startup circle. They're back in the circle, but you're seeing Goldman Sachs coming up their own stable coin. They have to use blockchain / Hyperledger for that. The Bank of International Settlements, which is the bank for central banks, where they go to get regulations passed. It's governor, I forgot his name, but he said that more central banks are gonna issue stable coins. They're gonna use this type of technology. You know, this stuff is very, very important, and it's there at our fingertips. Only thing you have to do is just go to the website, get the information on how to study, and do it. I'm going to stop right here because I feel like I'm about to curse.
Yeah. Blockchain developers on the market right now the salaries are going anywhere between $130,000 to $150,000 on an average. So anywhere, and this is outside of New York. In New York, you're talking at least 200,000 for a blockchain developer. The last time I spoke to somebody in November about a blockchain opportunity out in New York City, he told me what the salary was, and I said I don't even have my certification, and he was definitely adamant about paying that salary. So
yeah, Mike is right. I was inquiring just in IT because I know Nakamura Bank, Japanese bank, is actually looking at they're looking at blockchain developers. Maybe you guys, I want to look into that a little bit, but they're hiring consultants at $110 an hour.
Yep.
110 an hour.
Yep. That sounds about right. Gabe, you have anything you want to add to about blockchain developers?
Yeah, I was kind of maybe not exactly blockchain developers, but definitely towards Anel's point of being able to add different technologies and competencies on top of what you already know in order to be more marketable and be able to really have your hands in multiple pieces of technology. On Twitter, I don't know if you guys are on Twitter, but like tech Twitter is it's a very interesting place.
It is. It is.
Yeah,
it
it's
is.
a very interesting place. And somebody posted something that I had an idea towards. They posted that all these job boards, all these companies are looking for like an IT unicorn, right? And this IT unicorn is like, right, if you look at job descriptions, they say you need to have 50 years of experience, 50, 60 certifications, and all these different things, all these different exposures to all these different technologies. And my response, maybe not the best, not the friendliest or the most popular, but I was like, you don't have to be a unicorn, but you can become unicorn-like, right? It's not so much that you have to meet every single job requirement or job piece, but if you are continuously developing your skill set, you will find those verticals in different technologies. You will become more and more marketable to your field just because you are a continual and a lifelong learner and you're continually stacking more and more competencies on top of what you already know. So I would say you don't have to be a unicorn, but be more unicorn-like, where you're not just stopping in your one area of focus, but rather you're branching out and continually learning. So yeah, to that same point.
Yeah, I think
oh, go ahead.
Yeah, I think being more of a generalist rather than a specialist is probably more applicable to the situation here, right? The unicorn, right? This sort of person who's a jack of all trades, but probably a spade of none. You really don't want to get caught up in that unicorn act, primarily because you get a lot of things dumped into your lap, and you really don't have enough time in the day. Like today, I spent 3.5 hours in a meeting just doing threat modeling. So the other portions of my day was checking email, catching up and replying back, and different vendors and doing vendor risk assessments and things of that nature. I really don't have much time in the day to do anything else, right? So my day has already been fulfilled. But trying to be the jack of all trades, man, it could be very difficult. You just got to kind of narrow down what it is that you're really good at. If you're a network engineer, be the best network engineer, but also have the ability to speak to blockchain, the ability to speak to database architectures and things of that nature. You can actually speak to it. Like, it's the literacy aspect that's more important than actually being able to jump into someone else's chair and pull up command line and start pushing code through it. I think that's my advice.
Yeah, I agree with that. And I'll have to say the reason technology, things of that nature are very popular on Twitter is because Jack Dorsey is the owner of Twitter. He's pro technology. He's pro crypto. He's pro that. And right, exactly. And Twitter is where you go to just get the information from the horse's mouth. And it's just free flowing. And all that information is just follow the right people, get into the mix, link link your LinkedIn to your Twitter. Everything it's easier to network nowadays because of social media, but you have to know how to use it correctly.
Right.
Yeah.
Oh man, I'm thinking of Black Brain Trust Twitter should be in the making, unless it already exists.
Yeah, we would. We just got to clean up a few things, and we'll get to that point probably by the end of the summer. But yeah, we just got a thumbs down too. Find that to be very interesting.
Oh wow. Let me be quiet then. It's probably no.
Nagone is actually an IT recruiter, if I remember correctly. Involved in a consultancy, so he can probably speak more to what your skill set should be, what kind of things he looked for in a candidate.
Yeah, we do IT recruiting, and our staff are also we put together IT project management teams as well. So you always want to be on that. I want to get that hourly rate coming in through the firm on a regular consistent basis. But the bottom line is, what you guys are talking about is right on the money. I really like that comment about being a jack of all trades, because you can be that someone, but you got to be a master of one or at least two. But you got to be a master at something, and then knowing some other things is very good, because that makes you a better IT technologist. Some very good architects. I've run across some really good architects who are great programmers, great developers, but yet they had a lot of skills in a lot of other places, and they really knew how to put a lot of different technologies together and really work and really rock and roll, in a collaborative computing environment, and really be able to put a lot of stuff together. I've seen that, and not all architects are good, as we all know, but some are really excellent. Those are the guys who have a lot of skill sets, but they've mastered something. Usually, I've seen the guys who are really strong on the architecture side. I don't know why it is, but they tend to have a very strong development background. And had some skill sets on the DBA side or the sysadmin side, but yet they really understood a lot of different technologies, learned how to marry a lot of things together, and really work. This blockchain development game, anyone who's, let's say, somebody who may be coming out of, let's say, an Oracle developer or somebody else like that, then they've gotten into blockchain, and then they've moved out from Oracle and blockchain. They're very similar, as someone like Mike could tell you. Boom, these guys are commanding big bucks right now. I haven't gotten a lot of demand for blockchain as of right yet. And I said, there's one Japanese bank that I am currently trying to work with, where they are happening upon this. And blockchain developers, they're commanding such a high dollar, such a lot of money right now, because they're rare.
Yeah,
not a lot of them are around. They are rare, and the ones I see who are coming in this right now have come from Oracle development, from the Oracle side. Okay,
DBA side.
No, the Oracle developers, but also from the DBA, but Oracle developers. Blockchain, general ledger development, relational, that type of database development and management. They're similar. So these guys get into this. They get into these blockchain applications, and start to work it. They pick it up pretty quick, and that's it. But not a lot of guys. A lot more people will get on it, but right now a lot of people are just not on it. And so that's why they're commanding such a ridiculous dollar, 110, 115 an hour, and so forth. You can almost kind of name your rate right now, depending on where you're going. It's the big, heavy big bucks banks who are looking at these type of applications right now. So yeah, I can definitely speak to it. This is something that I'm just getting on, and I've learned a lot about blockchain right here on the Brain Trust. That is translating over into my business. This is something I'm learning right here. I've learned a lot right here.
Yeah.
I can't even front. And Master Lionel, and Master Mike, and these guys, they have been ridiculous on this. And I have to give them a lot of credit. They've helped me a lot more than you guys can know. Anyway.
Yeah, I hope you're saying master and not massa.
Master, well, it could be master and master, same thing, same tang, same team, man. Anyway,
Hey, Nicole, you and I are gonna have to talk on one of these days. Just have a good chit chat about blockchain.
yes, sir, yes, sir. And Lionel, I've been checking you heavy, man. You butter leg, very good. We'll do it.
Let me get to this next article. All right, this one is from NewYorkPost.com. Mars may have hosted life before Earth. Figuring this out. Angels pitcher Tyler Skaggs dead at 27. Interesting. Maybe Lionel could probably speak to that. A new study suggests that life may have existed on Mars hundreds of millions of years prior to its emergence on Earth. The red planet may have been ripe for life as early as 4.48 billion years ago, after life inhibiting meteorites stopped striking the planet, according to the study. And it's possible that life could have thrived between 4.2 billion and 3.5 billion years ago, according to comments made by the study's lead author Desmond Moser. Giant meteorite impacts on Mars between 4.2 and 3.5 billion years ago may have actually accelerated the release of early waters from the interior of the planet, setting the stage for life-forming reactions. Moser said in a statement, this work may point out good places to get samples returned from Mars. The study analyzed some of the oldest known Martian minerals, looking at zircon and uh, batolite grains seen in Martian meteorites, utilizing electron microscopy and atom probe tomography. 97% of the gains exhibit weak to no shock metamorphic features and no thermal overprints from shock-induced melting. The study abstract read. By contrast, about 80% of the study gained from the bombarded crust on Earth and the Moon show such features. The giant impact proposed to have created Mars hemispheric dichotomy must therefore have been taking place more than 4.48. Uh, what's the G stand for, Lionel? You know anything about that, or was that just a typo?
I don't know what the G stands for.
Probably gangster years ago.
Maybe.
With no later cataclysmic bombardments, Mars is generally assumed to have formed approximately 4.6 billion years ago, and the Earth soon followed, approximately 60 million years later. Life is generally assumed to have first appeared on Earth approximately 3.5 billion years ago. The research was published earlier this week in the scientific journal Nature Geoscience. That is very interesting. I'd be interested in understanding if they could find any fossils up there, because if they're saying that life was up there, what kind of life was up there?
I just looked it up. G is just to let you know that it's billions of years, just an abbreviation for billions of years. Yeah, that's pretty interesting to see how it, what kind of single cell organisms, amoebas, that thing, because that tells a lot. If it is a single cell amoebas, somewhat similar to Earth, that can rewrite, well, that can actually add to the story of the solar system. Well, if these things if these organisms that on Earth were on Mars too, well, what about Venus? Venus is like the same size of Earth. It's like 90% the size of Earth. What about that? So it adds to the story of the solar system. it makes it interesting.
Awesome points. As I said before, we had said in a hangout previously, examining the three major rocky planets, canceling, not talking about Mercury, but when we go to Venus, Earth, and Mars, looks like all three planets had oceans at some point in time in their past. Venus as well. Runaway greenhouse effect happened on that planet. Extremely thick, giant atmosphere, and temperatures now of 600, 700, 800 degrees Fahrenheit on the ground right now. So, hot enough to melt lead. So, whatever happened there, flipped that up, but it looks like it dried up everything, and everything went up into the atmosphere, and that's what it seems to suggest on Venus. Mars, we definitely have seen evidence that there was water. And and there's still some vestiges of water left on that planet to this very day, with respect to its ice caps. And we've seen where we've seen water flow patterns on, definitely on the rocks, with certain types of rocks that also would signify that they were underwater as well. And Earth is the only one that is still, ocean laden, if you will. It still has so these are planets. We're not even talking about the moons, if you will, where just between Saturn and Jupiter, we're looking at over 100 moons. Okay, and we've already looking at a few of them, where let's say Europa and Io and all of them seem like that these small planetoids or moons might actually have oceans, quite a bit deeper than we have, going down maybe 200,000 feet or so, or close to that. So we, this doesn't surprise me at all. I would expect that, to be quite frank with you, with planets that have so much water. Jupiter has a lot of water in its atmosphere, a lot. It's a majority of it is H2O, of course, with ammonia and many other gases that are there, as well as Saturn as well, with some very very, very interesting characteristics about those gas giants. But yet it seems like their moons, may have oceans too. So this is not strange. Mars. We remember there was a Mars rock that we found that looked like there was a fossil in there that looked fossilized like a bacterium that we might see here on this planet. And they said, no, this is not it. This is not it. And people tried to erase that and say that wasn't, but it looks so much like a fossilized bacteria. People are believing that is the case. They just don't want, there's a lot of issues with respect to religion and all this other kind of stuff that you can really get into. So talking about life outside of the earth. And I believe that there's a political move to see to it that maybe they don't talk a lot about this. But I think I think there might be some evidence that Mars might actually have had some form of life on it very long time ago. And from what we can see here on the Earth, it seems though that planets that do have water and can exist in a rather habitable area, that life pops up pretty fast. Now, when I say habitable, let's talk about that. You can go to the depths of this ocean and you have what are called black smokers. You have these tube worms that can exist in superheated water of 600 degrees because of the extreme pressures. So it wouldn't exist in the atmosphere. It could exist down there. That's hot enough to melt lead. But here, there's animal or there is plant, some type of plant life that's there, alive under these extraordinary conditions. So it seems to me if there is a chance for something to kind of survive for a while, it could. There still might be something on Mars. Who knows? But yeah, I'm not surprised but by any of this. And I think when we really start to look around and really just look around our solar system, think about the rest of the universe, it would not surprise me that we would find some type of microbial existence somewhere.
Gabe, you have anything you want to add to this?
Nope, nothing to add. All good information.
Now, as a cybersecurity professional, how would you penetrate tests?
Well,
Another planet.
well, satellites are usually networked to some degree, right? So whatever communication protocols they're using to communicate, probably start there, right? And then try to intercept some particular data, decode it, put it through probably do some binary analysis on the data, try to translate what they're getting, and then
I
I don't
was
know.
being facetious there, Gabe.
Well, you listen. Hey,
I'm like the Black Seinfeld. I'm just mad, bright, corny.
no,
Got
you're
it really
fine.
catchy. Okay. Yeah, my name loves Seinfeld.
I do. I ain't gonna lie. And Fraser.
Oh man. All right, this next one is from iScience.com. Speaking of network signals, astronomers have decoded a weird signal coming from a strange three-body star system. Span this out. Once or twice a day, a strange object in the Milky Way blinks at us. Now astronomers think they know why. The object is called NGTS-7, and to most telescopes, it looks like a single star. Researchers at the University of Warwick in England started watching because it seemed to be emitting flares, but on closer examination, they noticed that its starlight dims briefly every 16.2 hours. When the astronomers zoomed in, they realized there are actually two similarly sized stars in the system, and that only one of them is dimming briefly in that way, suggesting that there's something dark circling on or just above the star's surface. Now, and someone, please mute yourself if you're not speaking. Now, in the paper posted to the preprint journal Arxiv, the astronomers offer an explanation. A brown dwarf is orbiting one of the stars, and in an orbit so tight it takes just 16.2 hours to complete. It's impressive that the astronomers involved were able to parse the complicated signal from the system. This entangling, where the intermixed light from the brown dwarf and two small young stars originally came from, said Hugh Osborne, an astronomer at the laboratory of the Astrophysique in France, who was not involved in the research. Interesting. To pull it off, researchers applied a similar technique to that used to detect exoplanets, measuring how the light dipped as the brown dwarf passed between its host stars and Earth. The dip represents the signal of a transit, a brief partial eclipse of the star by something too small and dim to see directly, even through a powerful telescope. Sorry. Detecting this system is probably the easy bit, Osborne told Live Science, because the star is so small and the brown dwarf relatively large. The transit signal is actually about 10 times larger than that of a typical exoplanet that turns up in the surveys of the night sky. A brown dwarf sounds pretty racial to me, not so much a sciencey.
Yeah. Oh, go ahead.
No, I was just gonna say that
I know a few brown dwarfs. I know a few brown dwarfs myself.
Man, you are one sick puppy. You are one sick puppy. You're a sick puppy, man. I forgot what I was gonna say. Now I've got my mind on brown dwarfs in the manosphere. This is ill.
A brown dwarf.
I'm sorry, man. I didn't mean to do that to you, bro. I'm sorry.
A brown dwarf is a failed star. It didn't get enough the fusion that a star makes or does to make. Go ahead.
It's a failed star.
Yeah, brown dwarf.
Yeah.
It's a failed star. It didn't get enough power to sustain itself. It wasn't enough mass and energy to sustain itself, so it's a failed star.
Nicole, you have anything you want to add to that about failed stars and communications?
Well, I do know. Well, they say failed stars. I don't know. Brown dwarf. It's not so much a failed star, but it was a star for a while. Stars have lives, have lifespans. Like anything else. So you have your red dwarfs, you have your white dwarfs, you have your brown dwarfs. You have different types of dwarfs out here. As far as stars are concerned, and a lot of it is related to their lifespans, how long they've been a superactive full star, then they start to lose power, and then they start to shrink down in size, and all of that. And a brown dwarf is kind of a part of that. So would Lionel be correct in saying it's a failed star? I would say overall, yeah, in the sense that it may not take on, it may not have had a very long lifespan. Some stars have lifespan. It's hard for us to say. We speculate, but we look at our star. Here is our sun, which is a star. Is somewhere around maybe 6 billion years old or so. We don't really know. It's hard. I know we try to age our solar system, but I personally don't think that we have a very accurate way of totally aging this thing. Maybe we can come within a certain level of a degree of accuracy, but I have some doubts about that as well. We can't even age the pyramids properly, so how are we aging these stars, properly as well? So anyway, but the lifespan of a star, they all vary, and some die out faster than others, and that's where kind of these various dwarfs kind of come into the mix. So yeah, that maybe started burn for a short period of time and died out quickly, and and that's what you get. So. Anyway.
All right, let me get to this next article. This one is from slashgear.com. TESS finds a small planet that sizes between Earth and Mars. NASA's TESS spacecraft has been finding exoplanets since it began operations. TESS, or Transitioning Exoplanet Survey Satellite, has now discovered the smallest planet it has ever found. The tiny world is called L9859b and orbits a distant star along the two other planets dubbed L9859c and L9859d. Scientists say that the system where the small planet, which slots between Mars and Earth in size, was found has potential for future study. Discovering small planets is difficult to do, and scientists say for atmospheric studies of small planets, scientists need short orbits around bright stars, but the planets are difficult to detect. Planet L9859b is only 80% of Earth's size and is 10% smaller than the previous smallest planet discovered by TESS. The star it orbits is called L9859 and is an M dwarf star that is about 1/3 the mass of the Sun and is 35 light years away from Earth in the constellation of Volans. NASA's Kepler mission has discovered an even smaller exoplanet dubbed Kepler 37b that is only 20% larger than the Moon. As for the other two planets in the newly discovered TESS system, L9859c and L9859d are larger than the Earth at about 1.4 and 1.6 times, respectively. TESS discovered all three planets by looking at transits or periodic dips in the brightest of the star caused when the planets pass in front of it. TESS monitors a sector of the sky for 27 days at a time. When TESS finishes its first year of observation next month, the L9859 system will have appeared in 7 of the 13 sectors that make up the southern sky. That will allow scientific team pouring the data to search for additional planets that may have gravitational impact on the planets it knows about. So, this is a just a picture of the planets. I know you have anything you want to add to this?
Yeah, there's a lot of planets out there. The only as technology advances, first we have to find other planets. If we want to live on a planet, there's other ways to live that doesn't just have to be on a planet itself. I forgot the name of these spheres, but I forgot the name of these spheres. But you to live on a planet right now, that with our current technology, you have to be in a Goldilocks zone, not too far, not too close from the sun. If it's an exoplanet, there's a way to habitat it to our liking, but there's a multitude of ways. Just looking on YouTube and people that know what they're talking about, like actual physicists that talk about this stuff, there's a multitude of ways to live in space other than a planet. But just this Earth is massive. I don't think people really understand how massive Earth is. You get the numbers. Earth is such and such, 800,000 miles in there. Things like that. But when you look at it, it's like, golly, Africa itself is so huge. Like 5 different continents can fit in it. So this stuff is huge. We're talking on a scale. We're now speaking on scales that is unimaginable to the vast, to 99.99999% of the Earth's population. Even when I tell people that, there's asteroids full of precious metals that are, 20 quintillion dollars, and I say, first you have million, billion, trillion, quadrillion, quintillion. People stop and say, well, that's a lot of money. That's a lot of zeros. If you're doing that on freaking 3 zeros, the scope of the universe, let alone the solar system, is unimaginable. So yes, I can actually believe this stuff.
Oh yeah, that's great stuff there, Leno.
I was gonna. Oh
no.
that's okay, go
Go ahead, Gabe. I'll go after you. Go ahead, brother. Go ahead.
No, I just had a quick comment. I just think a lot of textbooks are gonna have to get thrown away. I mean,
I mean,
Pluto, you name it.
yeah.
A lot of textbooks.
See, that's one of the big problems. I think that why a lot of information comes out, and a lot of these schools and universities and other stuff. They don't. The book business is a business, and people want to make money on their books and all this, and have to throw all that out and rewrite them and then redo them and all that. It's problematic. I think there's a lot of economics behind why people are not, up on some of the things that are changing. I mean, there was a big fight, just to call Pluto, take it out of a planet, make it kind of a planetoid and say that it's not a planet, but yet, it has a moon orbiting it, and then when you listen to Dr. DeGrasse Tyson, he's like, well, if Pluto was where the Earth would be, it would have a tail, almost like it would be like a comet almost. So, because it's so small in size. So, I mean, there's so much stuff that we could break down, but look, the mass of the awesome size of this universe is not comprehensible. You cannot comprehend its size and dimension. It's beyond your comprehension. It actually is. And if anybody wants to sit down and tell me, oh, I can comprehend the size of it, tell me what 5 billion light years looks like. Okay,
Right.
5 billion light years.
Now, that sounds about the length of time it's going to take to get reparations.
Right. And I can prove to them that it's incomprehensible because the unit of measurement that we use on Earth to measure our solar system is an astronomical unit. An astronomical unit is the distance from the Earth from the sun. There's nowhere on Earth that you can travel to that will give you a distance from the Earth to the moon or even the Earth to anywhere. So we gauge, our ruler is the distance between the Earth and the sun because that's the only thing we know. So we say, well, Jupiter is 26 AU or astronomical units away. That's the only thing we know. So when people say, well, I can comprehend it, they're just ignore those people.
You really can. I mean, you can. I mean, because when you're looking at these, these distances, it's incredible. These are incredible distances. I mean, light in itself travels 186,000 miles per second squared, 670 million miles an hour. And in 1 year, it travels 6 trillion miles. Can you measure does anyone have a measurement for 6 trillion miles? And this is light traveling at an immense speed. And this is how far it goes in the air. And
It takes it takes 8 minutes for the light from the sun to get to the earth.
sun to get to the earth,
8 minutes.
that's 8 minutes. So the sun could have blown up. You look at it in the morning and say, oh, yeah, the sun hasn't even, great morning. 8 minutes later, you would find out that the sun blown up. And once the effects would you would have a visual effect on this thing. But for 8 minutes, you wouldn't even know this happened. So people just don't. You're not comprehending the size of this universe. So as far as what we can conjecture upon with respect to planet size, star size, even is the star Betelgeuse that is makes the sun look like a tiny little marble next to it. I mean, it's and this is a star of unimaginable size. So what would be the habitable zone for a planet that would be orbiting around a star of this unbelievable size? It would be much further out, but yet the effects could still be the same. You just cannot. We are infants at this, looking at this. Our imaginations are what we have to work with primarily right now, which will take us far, no question about it. But what we can really see or really imagine, I mean, all this is anything is possible. So right now we're just still trying to get information in. We've only been looking at this relatively short period of time. I mean, we have Galileo and all them, and we even have others of more ancient times who were able to track the stars as well and predict certain things that were existing out in our not only in our solar system but out in the star system, out in the universe. So but how we're imaging all of this now is relatively new. It's a relatively new business, and we're just infants at this. So I say that anything's possible right now. Anything is possible, and anybody tries to sit down here and talk like they're a genius and know it all is bullshit. There's no bottom line to this as of right now.
All right, let me get to this next article. All right, this one is from space.com. Propellant exploration, drones are going interplanetary. Expand this out. Drones have already conquered Earth, and now they are heading out into the solar system. NASA announced yesterday, June 27th, that it will launch a life-hunting rotocraft called Dragonfly towards Saturn's huge moon, Titan, in 2026. If all goes according to plan, Dragonfly will land on the hazy, frigid satellite in 2034, and then spend several years flying around, gathering a variety of data and snapping amazing photos of exotic landscape. But Dragonfly won't be the first drone to fly alien skies. A tiny helicopter Scout will accompany NASA's Mars 2020 rover mission, which is scheduled to launch toward the red planet next summer and land in February 2021. The Mars helicopter and Dragonfly are very difficult vehicles with very different jobs. The red planet chopper is a stripped down technology demonstrated that weighs a mere 4 pounds and carries no scientific instruments, whereas the 8-blade Titan probe will be 10 feet long and carry a suite of sensitive scientific gear and have a total price tag of about $1 billion. Wow. And they'll explore very different worlds. For example, Mars' atmosphere is just 1% as thick as that of Earth. and is dominated by carbon dioxide. Titan's air is 400 times thicker than Mars and is mostly nitrogen, like Earth's atmosphere. Still, there could be room and reason for two missions to work together, said Dragonfly principal and investigator Elizabeth Turtle of Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland. There may well be some commonalities that we can leverage between the systems, Turtle said during a telecon with reporters. And we were very excited to see the Mars helicopter selected to fly and rotorcraft on multiple planets. Flying, excuse me, flying around on an alien world will definitely be challenging, she added, but it's not a crazy idea. Given that the core technology involved, highly autonomous rotorcraft, is very mature here on Earth. We think what we're doing with Dragonfly is innovation, not invention. Turtle said, we are applying technologies that already exist to another planet. Here's a video of it, and see if I can play it real quick. Oh, you got to be kidding me!
Hey, Mike, could I answer a question from the chat first?
Mm-hmm.
All right, I think it's Ellis Jackson. She Ellis, I think a comment was made. The light would still be there. We're talking about if the sun exploded, but maybe we'd feel a difference in heat. Well, we wouldn't feel a difference in heat. First, light travels much faster than, let's say, a wave of heat or a physical wave, even from sound or anything like that. Well, sound doesn't travel in space. You would feel it once it got into the atmosphere here on the Earth. But even that explosive, vibrational wave of energy that would emanate out from an explosion would not travel at the speed of light. You would see it first, but the physical effects of the sun exploding would come after. And so you would see it first, and you wouldn't feel any heat or anything else like that. You would see an explosion, which might, just like when we saw literally when they dropped the nuclear bombs, people didn't feel the effects of the bombs first. They saw this seething, blinding light where many people just, their eyes got, burnt out or whatever, but or they got actually X-rayed. To be quite frank with you, a lot of people got X-rayed out, and then the physical, wave came about. So the waves would travel fast in space because you don't have an atmosphere. But then as it hit the planet, it would actually start to slow down a bit. But you would see the light first, but before you would feel any differences in heat, because nothing travels faster than the speed of light.
Mm-hmm. I know I was going to say something. Go ahead, Lionel.
Oh, this not rover. I'm going to say rover, but this drone is pretty cool because now they've mapped much of Mars. Now you can really map it since satellites there. Map it more to the best. Map it enough, and what I'm trying to say, map it enough and as much as you can before you send humans there, and they can actually map more of Venus and other planets to send satellites, like you have satellites around Earth, send satellites to other planets, map it there. And this photo you have on the screen is very interesting because I know people say, well, how do you travel in space since there's no vacuum? On opposite sides of that rocket, there's engines. So one engine, which is on the left side, is the main engine. As you know, when you travel through space, there's no friction there. There's nothing to slow it down. So the engine's on the right side would actually slow it down because for every, I forgot the wording, but you need something to basically slow it down, whereas it'll just continue to go, 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 go. So that's is how you would do it. Well, any other comments?
No, we're going to read the next article.
Yeah, I don't have any either.
All right, this next one is from Universe Today. Sorry. Expand this out again. Earth to Mars in 100 days, the power of nuclear rockets. The solar system is a really big place, and it takes forever to travel from world to world with traditional chemical rockets. But one technique developed back in the 1960s might provide a way to dramatically shorten our travel times. Nuclear rockets. Of course, launching a rocket powered by radioactive material has its own risk as well. Should we attempt it? Nagone, you're gonna have to mute yourself up, please, brother. Let's say that you wanted to visit Mars using a chemical rocket. You would blast off from Earth and go into low Earth orbit. Then at the right moment, you'd fire your rocket, rising your orbit from the sun. Then the new elliptical trajectory you're following intersects with Mars after 8 months of flight. This is known as Hohmann's transfer, and it's the most efficient way we know how to travel in space, using the least amount of propellant and the largest amount of payload. The problem, of course, is the time it takes. Throughout the journey, astronauts will be consuming food, water, air, and will be exposed to long-term radiation of deep space. Then, in return, mission doubles the to need to resources and double the radiation load. We need to go faster. It turns out NASA has been thinking about what comes next after chemical rockets for almost 50 years. Nuclear thermal rockets, they definitely speed up the journey, but they're not without their own risks, which is why you haven't seen them. But maybe their time is here. In 1961, NASA and the Atomic Energy Commission worked together on the idea of nuclear thermal propulsion, or NTP. This was pioneered by Werner von Braun, who hoped that human missions would be flying to Mars in the 1980s on the wings of nuclear rockets. Well, that didn't happen, but they did perform some successful tests of nuclear thermal propulsion and demonstrated that it does work. While a chemical rocket works by igniting some kind of flammable chemical and then forcing the exhaust gases out of a nozzle, thanks to good old Newton's third law, for every action there's an equal or opposite reaction. The rocket receives a thrust in the opposite direction from the expelled gases. A nuclear rocket works in a similar way. A marble-sized ball of uranium fuel undergoes the process of fission, releasing a tremendous amount of heat. This heats up a hydrogen. This heats up a hydrogen to almost 2,500 degrees Celsius, which is then expelled out of the back of the rocket at high velocity, very very high velocity, given the rocket 2 to 3 times the propulsion efficiency of a chemical rocket. Remember the 8 months I mentioned for a chemical rocket. A nuclear thermal rocket could cut the transit time in half, maybe even 100 day trips to Mars, which means less resources consumed by the astronauts and lower radiation load. And there's another big benefit. The thrust of a nuclear rocket could allow missions to go when Earth and Mars aren't perfectly aligned. Right now, if you miss your window, You have to wait another 2 years, but a nuclear rocket could give you the thrust to deal with flight delays. The first test of nuclear rocket started in 1955 with Project Rover at the Los Alamos Scientific Laboratory. The key development was miniaturizing the reactors enough to be able to put them on a rocket. Over the next few years, engineers built and tested more than a dozen reactors of different sizes and power outputs. With the success of Project Rover, NASA set its sights on the human mission to Mars that would follow the Apollo landers on the moon. Because of the distance and flight time, they decided nuclear rockets would be key to making the missions more capable. Nuclear rockets aren't without their risks, of course. A reactor on board would be a small source of radiation to the astronauts' crew on board. This would be outweighed by the decreased flight time. Deep space itself is an enormous radiation hazard, with the constant galactic cosmic radiation damaging astronaut DNA. In the late 1960s, NASA set up the Nuclear Engine for Rocket Vehicle Application Program, NERVA, developing technologies that would make the nuclear rockets that would take humans to Mars. That's an example of the schematic that they worked on. I know, Nagone, you have anything you want to add to this?
No, I think that's, I've heard about that before. And yes, Werner von Braun and all of them were talking about that. One thing I want to say about Werner von Braun, he was, basically a Nazi, was a member of the Nazi Party, helped to develop the V rockets and all that to bomb Europe with England and so forth. So he was big in that, and then we brought him over here after the war, and he developed our NASA. Basically, he headed up NASA and developed our space program. But his view before he was recruited by the Nazis was about building, rockets to actually to inhabit space. So that's where this guy was really coming from. Not to say that he wasn't a Nazi. I never spoke to the man, and I don't know how he felt about Jews or others. But he was really more about developing outer space. Developing outer space, and that's what he was about. So nuclear thrusters on rockets and so forth makes a lot of sense. We have a lot of nuclear power. That would make sense. I think it's just a little bit dangerous, as anything else, because if you have an explosion or something, it's going to be nuclear. So, it could have, and then fallout and all that can come with it. So, be very interesting way of how we would manage that technology as safely as we could. But I definitely think it's a way to go. And if we can harness that power and get to these planets faster, I'd be like, yeah, let's do it. I also understood that they were going to try to use fusion and work with this kind of fusion technology, and then use these fusion sail types of sails that could travel at really almost at sublight speeds, but it would take a while to build up the power to do it. But yet once this thing was at full power, you could really travel at immense speeds, sublight speeds, maybe a quarter of the speed of light or something else like that. That can make travel very quick. But these nuclear thrusted rockets, I think, I think that's a technology that we could get to pretty quickly.
Mm-hmm. Yeah, I was going to say kind of aligning with some of those. I used to work as a nuclear engineer at a commercial nuclear plant, and having a reactor, it really is kind of. They probably have to borrow, or probably have already borrowed a lot of the technology from, because nuclear reactors run on submarines, like naval
they do. Yeah,
submarines. So they'll probably borrow a lot of the similar technology. But I'm thinking that the amount of power that they'll need would probably scale even higher than that of. You're thrust through through space and timing and all that. So I know that one of the, like you were saying, one of the major concerns was that of safety. And coming from a reactor, there's like those three different types of rays. There's the alpha, the beta, and the gamma rays.
Gamma rays, yeah.
Right, where the alpha, alpha rays, they're the most damaging, but they don't have very good penetrating power, right? They can only go as far pretty much as like your skin.
Right.
But then you have beta, right, that is able to kind of penetrate the human body, not as damaging, but can be stopped by like a piece of paper or something, right? Or lead really is what you really want to use. And then you have your gamma, which has very good penetrating power, but usually you use concrete to stop those type of rays.
Concrete,
so
some levels of graphite as well, from my understanding.
Absolutely. So I would think that probably the type of shielding for safety for the astronauts would be something that would be very important in transporting people for 100 days, right, at a time. They'll need to have some pretty strict safety and shielding from the reactor running on board the spacecraft. So
yeah. I mean, I definitely think that they could firewall some of this for sure. But as in any human system, there's going to be just inherent problems built in where you're going to have some kind of catastrophic event at some point in time. And we'll have to deal with that, I guess, as the development of that goes along. But if they can make this thing relatively safe and operated, I definitely think it's a useful use of that technology. Certainly, if you can use nukes, and we've got them to travel space, would be great. I'm sorry, Mike. Go ahead.
No, I was just going to say that the other article I think we've covered before, and they've been talking about this for quite some time, is actually using the nuclear reactor to power the new engine, which would be basically plasma based.
Yeah, that's what we were talking about with plasma and infusion. Yeah, with the sail, with this nuclear sail business and all that. But I've been looking at all this stuff. You were actually right about that, Mike. Where they fire this beam into it, which actually into the sail, which actually drives you, and you can get sublight speeds on that. I've been looking at that. I mean, the ideas that we have are pretty. I mean, this is what I say. The ideas we have are advanced, but from a technology standpoint, we're like right there. We're right there. We're like right there. So so we can do this. This is doable, and this is doable kind of like now. Not in 50 or 100 years. This is doable now. So
I find it interesting that the beta is actually a stronger component than the alpha, and the manosphere is something backwards, right? It's nothing.
I knew it was coming.
Mike can't resist it. He can't resist. Mike can't resist.
Yep. Alpha is definitely the strongest, but penetrating power isn't. The ability to penetrate isn't there, right? Not as much. We're in the manosphere, right? Penetrating power to beta is low. I'm done with that joke.
Hey, Dr. Phoenix is on the panel. Welcome, Dr. Phoenix. What's going on?
Dr. Phoenix.
Good evening, gentlemen. How's everyone doing?
Greetings.
Chilling, brother. Chilling, man. Chilling.
Hello.
Yeah, what's going on, brother?
Where is he?
We haven't been properly introduced, Linnell. So, how you doing, brother?
Hey.
I'm good.
Nice to meet you, man. You're in the same field as my wife. She's a ICU nurse.
Yeah, I remember your broadcast, the interview O'Shea did with you a couple weeks ago. Yeah, because I was talking with some of the gentlemen in the chat and stuff like that, and was talking about some programs that they were interested in, like getting into CRNA school.
Right.
So
right.
Yeah.
Man, and I feel like I'm right in there with y'all because she tells me about the field and the profession, all the dynamics, even the politics that happen within the field. So yeah.
I mean, it's healthcare. I mean, healthcare is really stratified. Lots of politics. I mean, it's different every place you go. So I mean, it really is just one of those things where, it is organizational dependent. So it can get real crazy. So.
Because she even talked a lot
congratulations
about
to your
even.
wife, man. So,
Oh yeah, absolutely, man. It was. I mean, it was about a year and a half. No, almost 2 years that she was applying, and
yeah,
she was
it's
working as ICU nurse. It was
that
a
school
very
is
competitive.
it's
Lord.
really hard
Yep.
to get into.
Yep.
Typically, most folks who want to go that route, I mean, again, I mean, it's a really high paying career.
Indeed.
Um, you just have, I mean, it's just really competitive. A lot of folks try to get to it. You need at least a year of ICU experience. A lot of the programs ask for you to have a CCRN
Yep.
certification.
Yeah, she got her
So,
CCRN. Yep.
yeah,
We were
yes.
studying and praying. Yep. Absolutely.
Dr. Phoenix, you have anything you want to add about nuclear engines and space travel?
I think in general, Nagone covered it when Nagone and Gabe covered it when you're just talking about, the various forms of radiation and stuff like that. I guess my major concern would be, one, just, having that in the atmosphere when you're talking about escape velocity and stuff like that. And also, what happens in the event of a failure, again, we saw what happened when the tanks on the Challenger exploded back in '86. So I guess my major question would be making sure there are adequate ways to keep the reactor cool and stuff like that, even in the event of a failure. So
yeah, because in nuclear environments, especially in commercial nuclear, there's so many different safety mechanisms associated with failure situations, right? It even gets to the point of manual restarts, manual manual processes involved in the event of a failure, right? A complete radiation exposure to certain areas, like sectioning off. I mean, on an aircraft, how many measures and what measures do you have in that event is very interesting to find out.
Well, I think even here in this country, I mean, they had banned nuclear power plants from being built for years.
Yes, they did.
And they're closing back and forth,
especially after 3 Mile Island and all that. No question about it.
And what was it? Fukushima about a decade or so ago.
And Fukushima, they were lucky because
Chernobyl.
There was one wall that would have come down. That literally in that flood, if that came out, everything would have come out of there. It would have been
absolutely.
Yeah,
really good.
And Chernobyl, those guys actually went in there and closed this thing and poured cement and did what they had to do by hand. They did that. And
if you still go to Chernobyl to this day, I mean, there's still high radiation readings there.
Indeed. I mean, the radioactive decay. I mean, come on.
But they're seeing animals come back and grass grow and all that stuff right now. I think they have nuclear tourism over there in Chernobyl.
Well, they say you can only be exposed for they had some old people because as you know, with the labile and stabile cell populations that we have in our body, older people who are very old, they just have a lot of older cells and they're not going to be as easily as affected. But kids and women and all that, who have a very active labile cell population where they're constantly, sloughing off, like periods or whatever, and kids are growing and their bones and all that, they'll be uptaken very quickly by that. We'll kill them, but older people can actually stay in that area. But they do say it's still uninhabitable as far as no new buildings or anything like that are going up, and then people can't move into the area. So whoever was older and was left there, they stayed there. But they do say that it's dangerous. They're saying that the sarcophagus has actually started to leak a little bit. So they're actually looking to reseal it because as the Soviet Union actually went down, funding for actually trying to fix that was had some issues with that. So that's still a rather touchy situation there. So go ahead.
Hey, I'm gonna catch you guys later. I gotta get this somewhere. Get this up.
Okay.
See you later, Lionel.
All right, God, go.
All right, you too, brother. Yeah, I think with Fukushima, they ended up pouring I think they were saying like billions of gallons of seawater into the reactor to cool it off. I mean, and
They were they're still saying there are big problems there because they were saying that you could pour every ocean on Earth on that, and you still couldn't properly cool it. So they had some real issues with that, man. I mean, they fucked up. They shouldn't have built that. Pardon my expression. I'm sorry to say. I mean, but they I don't know if they were too bright in where they built that reactor. So they can't build any more nuclear reactors right now in Japan. So
nope.
Right, and that's why there's a lot of
Yeah.
that's why there's a lot of discussion about getting energy from Russia. So-called islands have energy trapped in them. So, but you also have to take into consideration the attack on the Iranian nuclear facility as well.
Yes,
Stuxnet.
Stuxnet, absolutely. But have you heard? I
Also,
actually was supposed to go over there for a contract gig. There's a new nuclear plant, actually almost in the process of starting up, called the Baraka nuclear plant. It's probably about 2 hours east of Abu Dhabi. So they're going to be starting up pretty soon, within the next year or so. This will be the first one and the only one within the Middle East running. So. Mm-hmm.
Yeah, and they also there was also attack on the German nuclear facility as well.
Yep.
I think a year or so ago.
Yes.
Same Stuxnet attacks. Yep.
Mm-hmm.
I will say this much in regards to nuclear power. I think, Gabe would know this given his background, but, nuclear power still is one of those nuclear plants. It's still one of those extremely heavily regulated industries. So
extremely. Absolutely.
Yeah. Just because of the nature of, what's involved and stuff like that. Mm-hmm. But also, too, when you look at some of the byproducts of nuclear power, I mean, you get like stuff like depleted uranium, you get cesium and stuff like that. And, depleted uranium is used as armor-piercing rounds, the military uses. And so, I think, just in the Iraq war alone, I mean, they got readings, they get readings from just the soil in Iraq because, of course, the U.S. just...
Yeah, I mean, you bring up a hell of a point because you did have a quasi-sub kind of nuclear battlefield. The depleted uranium, and what a lot of people don't understand is the depleted uranium, because it has a level of radioactivity. You don't even have a charge to explode it. You just accelerate this thing at a speed and hits it, explodes.
Yeah, it explodes
and it explodes with heat, and it can penetrate tanks and everything else like that. And there is radioactive fallout from that. And people were talking about, there was a disease that people were saying, they came back with the Iraq war disease or something. There was some disease that they were calling it at the time. And they were saying, well, it was what we were exposed to. And ultimately it's coming down that this disease that they were talking about were people who were exposed to certain levels of radioactivity. And they never spoke about that you were on a radioactive battlefield because of depleted uranium rounds. And this is supposed to be your nuclear waste that they have from depleted uranium. The military picks up and make weapons out of it. Yeah. I mean, it's just it's unbelievable. But anyway,
and that's the interesting thing. Like I say, my background, I was a medic in the U.S. Army, and I was in Iraq. In fact, I was in Iraq during the assault on Fallujah. Right. And so, this is one of the key things. When I got there, we had to get a lot of the training because they obviously knew that they were using depleted uranium rounds. Pretty much everything you see got shot out of a tank, got shot out of one of the Apaches, whatever, the howitzers, all of it had depleted uranium in it. And so one of the things what will happen, because the rounds are actually pyrophoric, they ignite in air, and so they oftentimes would hit tanks, and so the tanks would explode and people would get trapped inside the tanks, and so just the burning itself would let off various types of gases, and so soldiers would get exposed to that. And now obviously anybody knows the history of the military and the VA and stuff like that. It's only in recent years they even just come around to even finally acknowledging what Agent Orange did to service members. And so now we don't even know the effects of just using depleted uranium. But I mean, you can Google this, but there were a number of articles that came out in the BBC and some other outlets that were talking about, just the how many of the soil and water sources in Iraq are currently poisoned because, if I remember correctly, depleted uranium has a half-life around 3.5 million years, I believe.
Yeah.
Something like that. Yep.
before it turns into a more inert product. But we know the sicknesses. They're trying to hide it. But we know, and we certainly have major studies after Hiroshima and in Nagasaki as to what happened there. That was very extraordinary. But we do know what radiation and some of the radiation sicknesses look like. We know what they look like. We know what that produces. A lot of it is genetic, and we definitely are seeing genetic malformities with some of the kids that are there. But we're looking at, many of the other diseases that go along with this kind of poisoning with respect to various cancers and neurological diseases and so forth.
Even
we're
speaking
seeing
on
that. We know what's going on.
Even speaking on that, and even kind of towards the point of the regulations, so the regulatory body, right, for the commercial nuclear industry in the United States is called the NRC, the Nuclear Regulatory Commission.
Yes,
and they also are there in healthcare too, right, because they have radiation uses. Kind of towards that, part of the training that we do when we come into a commercial nuclear plant is that they give us education as it concerns individuals who are pregnant. If you know that you're pregnant, you can't go into certain areas of the plant, right? If you are a male, right, they also warn you against your inability.
Genitals.
It might be, right? Yeah, it messes up with your sperm count and your ability to reproduce. So this knowledge is, it's kind of, watered down and kind of a derivative of what they actually know as it concerns the effects of radiation or even occupational radiation on the human body. So, I absolutely agree with that.
We know what's going on. We know that there's a stable cell population. Some very thick nerve fiber tracts and certain kinds of muscle cells and so forth that you may have that are very stable. So they're not going to break down very quickly. Okay, but any population in the body that reproduces quickly, cell populations that reproduce quickly. Like your epithelial level areas, the squamous epithelium and so forth, as we want to get more specific there. We can look at also a woman's reproductive system, that's constantly, changing over. Certainly, the testes in younger males, more so even than older, but younger, that are producing, spermatozoas very, very quickly. These are, your you have your stable, but these are your labile cell populations that are going to get adversely affected very quickly. Certain organs are going to take up your thymus and so forth, are going to pick up the thyroid. They're going to pick up these poisons very quickly. So we know what's going on. We see what's happening with these people. We know what's happening. But they took a lot of that out of the press because they just didn't want you to know.
Yeah, I would just add to that, in specific areas within healthcare, for example, oncology, interventional radiology, interventional cardiology. Most people don't know if you go into a catheter lab. I mean, they, the interventional cardiologists, they're using it. We use barium, stuff like that.
Barium swallows and stuff like that. So
exactly. The swallow studies.
That's right.
And so again, they say that a lot of stuff like the barium is harmless. I'm not so sure about that.
Don't buy any of it.
But I would tell you this much because, as I think I was talking about this on the very first panel I came on, but I currently do research with a wound care doctor, and he uses hyperbaric chambers. And so we know hyperbaric medicine and hyperbaric chambers in generally are used to treat radiation sickness, radiation damage, especially from those who underwent cancer. And there was a specific case I had last week with a patient who had esophageal cancer.
Okay, and that's tough one. Okay.
Yeah, he went through radiation and chemotherapy, and basically he's been 8 years cancer free. So technically he will be considered cured, because if you guys aren't familiar with the mortality rates of the esophageal cancer, is right up there with pancreatic cancer.
Yeah, absolutely. Would you go into just tell this people very quickly what hyperbaric chamber is? Just very quick. I'm very familiar with it, but just kind of drop that on people for a little bit so they understand.
So basically, hyperbaric chambers use use 100% oxygen to hyperoxygenate cells. Usually allows for the uptake of oxygen within cells of 18 times the normal amount, and that in turn facilitates what we call let me make sure I get the term correct. A response, an immune response in a cell. And so what happens is that the cells begin to multiply and you begin to produce normal, healthier cells. And how is that important? Because, normally at standard atmosphere, 1 atmosphere, ground level, whatever, sea level, excuse me. And so typically we do it at 2 atmospheres, which is about 33 feet. And so essentially the whole point of it is to facilitate increase the uptake of oxygen into cells, so hyperoxygenate cells, if you will, and that in turn facilitates healing. And how does it happen? Because for folks who undergo radiation damage, no matter what kind of radiation, and in particular in healthcare, tend to use is ionizing radiation. And so, so what happens is that you get the 3 H's of what we call hypocellular, meaning you get a lack of red blood cell produced in that area that's been affected. You get hypovascular, meaning you get a reduction of blood vessels in that area. And then you get what we call hypoxic, which means that the tissues begin to get starved of oxygen. And so for folks, for example, with the gentleman I was just talking about with radiation damage because of the treatment he had to his neck and to his neck throat area. But essentially I had to I was doing a physical exam, and so I got a chance to feel it. And it was the first time I really felt somebody with radiation damage. And this gentleman in particular, his neck was about as hard as a brick. It was that, so what happens is that when you get radiation damage, you get scar tissue that forms. And so the scar tissue does not function quite as efficiently and normal as normal tissues do. And so it becomes fibrotic, and it just becomes hard. And so, and what happens with this particular guy is that he began to experience a lot of swallowing issues. It takes him about an hour to eat dinner and stuff like that, because again, this is one of these areas where I'm not the biggest fan of radiation chemotherapy. I just put it that way. But again, because of long-term side effects, and actually, me and Complex talked a bit about this because we just talked about this a few days ago. But again, so in the case of this gentleman, we use hyperbaric chambers to treat everything from diabetic wounds, diabetic foot ulcers, which is probably about 2/3 of the patients. I take that back, maybe about 3/4 of the patients.
All right, let me get to this last.
But I'll just leave it at that. Yeah, I'll just leave it at that. So.
Yeah, thank you for that. All right, this last one is from EurekaAlert.org. Researchers teleport information within a diamond. Researchers from the Yokohama National University have teleported quantum information securely within the confines of a diamond. Need to mute you up there, Dr. Phoenix, please.
I'm sorry.
The future of how sensitive information is shared and stored. Researchers published their results on June 28, 2019 in Communications Physics. Quantum teleportation permits the transfer of quantum information into an otherwise inaccessible space, said Hideo Kosaka, a professor of engineering at Yokohama National University and an author on the study. It also permits the transfer of information into a quantum memory without revealing or destroying the stored quantum information. The inaccessible space, in this case, consisted of carbon atoms in diamond. Made of linked yet individually contained carbon atoms, a diamond holds the perfect ingredients for quantum teleportation. A carbon atom holds 6 protons and 6 neutrons in its nucleus, surrounded by 6 spinning electrons. As the atoms bond into a diamond, they form a notoriously strong lattice. Diamonds can have complex effects through complex defect. Sorry, though, when a nitrogen atom exists in one of two adjacent vacancies when carbon atom should be. This defect is called a nitrogen vacancy center. Surrounded by carbon atoms, the nuclear structure of the nitrogen atom creates what Kosaka calls a nanomagnet. To manipulate an electron in a carbon isotope in, in the vacancy, Kosaka and the team attach a wire about a quarter the width of a human hair to the surface of the diamond. They applied a microwave and a radio wave to the wire to build an oscillating magnetic field around the diamond. They shaped the microwave to create the optimal controlled conditions for the transfer of quantum information within the diamond. Kosaka then used the nitrogen nanomagnet to anchor an electron. Using the microwave and radio waves, Kosaka forced the electron spin to entangle with a carbon nuclear spin. The angular momentum of the electron in the nucleus of a carbon atom. The electron spin breaks down under a magnetic field created by the nanomagnet, allowing it to become susceptible to entanglement. Once the two pieces are entangled, meaning their physical characteristics are so intertwined they cannot be described individually, a proton or a photon which holds quantum information is applied and the electron absorbs the photon. The absorption allows the polarization state of the photon to be transferred into the carbon, which is mediated by the entangled electron, demonstrating a teleportation of information at the quantum level. This is probably the biggest game changer I've seen in years. I don't even know how to react to something like this.
That's off the chain. That's off the chain, because now you're talking about changing the orbitals that these electrons are traveling on, and using a nitrogen atom to help to facilitate a magnetic field to help to transport this information across from one carbon atom to the next.
Mm-hmm.
And then information will be carried. I'm just sitting there saying, what? This is highly butterlaid. I would have to really look at this, because I understand chemistry well. I understand how these orbitals move. I'm looking at this from a nuclear. Damn. So these guys actually physically could put a wire in here to transfer this through a nitrogen. The nitrogen atom. This is ridiculous. How long have they been doing this?
I've heard about the Americans and the Russians and the Japanese all working together on this for some years now. In terms of teleportation, China has been working on this extensively to this very moment. And the last thing I've read about China is that they've been able to figure out how to go forward, but not to come backwards. They haven't figured out how to get a person to come back, or an object to come back. Sorry.
I'm wondering, at this quantum level, could this information be split to exist in two nuclei at the same time in different places? I don't know. I would really have to look at this deeper. This is crazy. This shit is crazy. This is crazy.
Yeah. I wish Lionel was here. You could probably put all this information on the blockchain.
This is crazy.
Mm-hmm.
Wow. Teleport.
No, this is next level. This is next level stuff, and we know Africa has lots of diamonds in the ground, so we'd be able to reenact this experiment on our own. That's just a hypothesis. So.
Wow. I would like you to run that back again, but I know you. I know for the sake of time you can't do it. But I gotta really wrap my head around this. This is heavy.
Mm-hmm.
That's deep. That's deep. Wow.
I know, it's amazing, isn't it?
Yeah, I mean, just the just looking at the electromagnetic transportation. I mean, it's one of the fundamental forces of nature.
Yeah.
Electromagnetism, but just looking at how they're using that as a transporting information.
Yeah, I knew they were doing quite a bit of research in Tel Aviv, using supercooled magnets,
Right.
using nitrogen and supercooled magnets for levitation. So, I mean,
Yep, absolutely.
so I mean, this is the next logical step, obviously. So, I mean, wow.
Yeah. I mean, I understand certainly. There were experiments that they were using. Actually, Einstein and an Indian scientist named Bose. They were, Einstein was also dealing with what a lot of people like to say in alchemy, if you will, but it was really more from a chemical perspective, and they were dealing with substances that how they reacted or functioned, literally right, at super cold levels, literally just beyond, just above absolute zero. And they were able to produce what was called a Bose-Einstein condensate, and this condensate was a state of matter, if you will, that permitted certain kind of things to happen that wouldn't happen in a normal environment, like slowing light down. A light beam would be slowed down as it came through this condensate at a very slow speed, and it would speed up as it came out. Therefore, you could use this supercooling type of condensate to be used in quantum computers to hold information, and hold a lot more information in there as you could with a regular computing system. So this condensate played a key role in quantum computing, with holding information by keeping these computers super cold. And just some of the states of how certain things would react, like a fluid would act like a super fluid under these conditions, and so forth. Electrical conductivity could be slowed or sped up, at any rate almost that you want under this condensate. And they use that actually in supercomputing, or quantum computing now. But this diamond piece, that's just a game changer, bro. I'm a little. That's a game changer. Wow, I know that they were messing around with that, but using this as teleportation, it's and around a carbon lattice using nitrogen.
Yeah.
I just like I said, I'm a little remiss on this. I'm gonna have to look at this a lot more. But wow, that's highly butter laden. I mean, these guys are rocking. So these brothers, sisters, we got to get up in this, man. We got to be on this stuff. We got to be in this. This is highly butter laden. This is incredible. So wow. Anyway, I'm done. Wow.
Hey, Dr. Finch, you have anything you want to add to it?
No. I mean, Lagone said it all. I mean, I guess the only thing I could add would be, I mean, as as black men, we're wholesale missing the damn bus. I mean, yeah. I mean, I think earlier I was listening to some of what you guys were talking about earlier in the discussion, and you guys were talking about life forms on other planets, on Mars and stuff like that. And some of the another big area of research was where they were looking at silicone-based life forms, because silicone is pretty much the sister to carbon. It acts and functions like carbon, makes very stable bonds like carbon, and so yeah, in fact, it's been rumored that it could replace carbon in many respects. So I mean, this is just something where we as black men, we need to be wholly engaged in, even if this is not our particular area of expertise. But we need to be able to be wholly engaged in, and also be pushing the next generation into these fields. Because again, this is stuff we're talking about that's happening. I wouldn't even call it theory or anything like that. It's happening on this small scale. And, and certainly in our lifetime, I would not be the least bit surprised where this stuff is just commonplace. We're talking about it here more so in the abstract, but, I wouldn't be the least bit surprised in our lifetime. We'll talk about this as an everyday occurrence.
Wow. This is deep. I'm sitting here. I understand what the implications of this is. Just so if you're transporting a lot of information this way, I wonder what else will be able to be transported underneath a technology like this later on. This is incredible. It's incredible. Wow. Great information, Mike. That's great.
Yeah, dope. Any closing thoughts before we close out?
Highly Butterlate Hangout. I know not a lot of people are going to listen. This is not exciting to a lot of people. I understand. There won't be a lot of fighting and cooking and roasting on this kind of thing. But this stimulates my frontal lobe like nothing else. This is the kind of stuff I love. I love this. So anyway, no, great hangout, man. Highly Butterlate, great stuff. Glad to be here tonight. Anyway, I don't have anything else to say. I'm still thinking about this. It's going to send me to my computer tonight. It's crazy. But anyway,
yeah.
Great stuff, Mike. Great stuff.
Thank you. Also, actually, we'll let you, Dr. Phoenix, actually carry out his closing thoughts.
Yeah. Again, I agree wholesale with Nagone, and again, these things aren't necessarily sexy. There's none of what I call the YouTube Maury show drama, whatever. But again, this is stuff that we cannot overlook because, again, we were just talking about radiation and stuff like that, and I can tell you how I see this every day. And so again, these things we're exposed to these what we would consider theory. Many of us are exposed to this in our everyday lives and our careers and such, and we don't even really notice it. And so again, it is certainly the onus is on Black men to bring ourselves into the 21st century, as I like to say, and be engaged and engage our minds and engage the young Black boys. Help them understand this, because I heard what you and Gay were talking about at the very beginning about, he was trying to get his 13-year-old. If you guys remember what I said last night about that critical development period is from birth and really even in the womb to about 5 years of age. And, so again, that's where you need to be planting those seeds for to not just have discussions like this, but to create the next generation of physicists and scientists who can do this work. So I'll just end it there.
Yeah, absolutely. Chaos reigns. From what you heard tonight, 30 seconds. Your closing thoughts.
Good show. That's all I gotta say.
All right. Also, an announcement. We just broke 1,600 subscribers. Just in the last hour or so. So, thanks to all those who signed up and subscribed. And please hit the like button if you have not already done so before this hangout ends. And share the video if possible.
How the hell do we got 2 thumbs down?
And it's mind-boggling. It's very mind-boggling.
Yeah.